Pleased to welcome back a regular guest of the speaker series, Dr. Jon Noad. Jon is a geological specialist working for Husky Energy in Calgary. Jon obtained his undergraduate degree from Imperial College London. After working for a few years as a mining geologist in South Africa, he returned to the UK and joined the phone company BT as their marine geologist responsible for analyzing submarine cable routes. During that time, Jon completed a master's degree in sedimentology at night school, with his thesis focusing on the fluvial sequence stratigraphy at Dinosaur Provincial Park. Upon completing his thesis, Jon returned to London University as a full-time student, working on his PhD on the sedimentary evolution of eastern Borneo. After completing his PhD, Jon was recruited by Shell and worked mainly on Middle Eastern exploration projects before moving to Shell Canada in 2006. There, he worked as a senior exploration geologist in the Basin Sander gas team in Calgary until he joined Murphy Oil in 2010 as their exploration manager for Canada. Then in September of 2012, Jon moved to Husky Energy to work as a geological specialist, where he manages the new graduate program and geoscience training courses, as well as leads the occasional field trips. Today, Jon will use his geological expertise to discuss aspects of the 2013 Southern Alberta flood. What were the causes, what were its consequences, and what is the potential for a recurrence of similar flood in the years to come? So, without further delay, I present you Dr. Jon Noad.
Thanks. Well, good morning, everyone. Clearly a popular topic. Thank you very much for coming today. As you can see from the title, we're going to be talking about the Great Flood, Alberta's biblical deluge of 2013, and the biblical is taken from several of the news agencies that reported on it at the time. Now, before I start, I just want to say a couple of more serious things. The talk itself will be relatively light-hearted, but tens of thousands of people have been killed by flooding around the world, and we were actually incredibly lucky in Alberta that only 3 people lost their lives, so that was actually very lucky for us. The opinions in this talk are entirely my own, not my employers, and I think I should probably also say not the government's, because the government has set up some kind of think tank which is looking at the floods, but it doesn't involve many technical people as of yet. I'd like to thank the various news agencies whose pictures I've used, and it was actually quite a challenge to get hold of them and ask their permission, but I think it's been worth it, as you'll see. So the images, some of them are mine, but many are taken from the news. And I'd just like to say you can download this after I've given the talk, but please don't reproduce any images without asking for permission, because otherwise they could sue you, theoretically. And I'd just like to thank Jerry Osborne of the University of Calgary, because I had some great chats to him about flood frequencies, which we'll go into a little bit later on. So, as we know, on June the 21st in 2013, over 100,000 people were evacuated, which was Canada's largest evacuation ever. And the flooding in Alberta over the following week was the costliest disaster in Canadian history. And as you can see here, the actual insurable cost was $1.7 billion, but the real cost was probably three or four times that. And today we're going to look at how the flooding started, what contributed to the scale of the flooding, and how it impacted Calgary. And I picked on Canmore as the other place because I went to visit Canmore and looked at it extensively. I'm not an expert on what happened to Drumheller during the floods, but I'm sure many of you guys are. And we're going to talk about some of the geology and some of the weather and how that influenced things. And we're going to ask, was this really a biblical deluge? And what's the chance of history repeating itself? And you can see I have a couple of images here as well, just to check that the pointer's working. And this is just to show the declared states of local emergency that were declared over southern Alberta. And you can see over 40% of southern Alberta was in a state of emergency. And just as a little background, I was supposed to lead a field trip on June the 21st, and I thought I'd just check on my computer before I headed out to go and pick up the students that I was taking out to the field. And I was supposed to be going to Canmore, so I put my computer on and I brought up Canmore weather, and my screen was flashing at me, and I thought, well, this is a little bit odd. And that was the first state of emergency that was declared, was in Canmore itself. So obviously my field trip had to be cancelled, but that was my introduction to the flooding. So we're going to start off by talking about the Bow River Basin and where all the water actually came from. And as you can see here, most of our water originates above the Pacific in the normal course of events, comes over BC, and the precipitation that we get ranges from around 600 millimeters a year, so about that much a year. in the mountain areas to around 300 millimeters on the eastern prairies. And you can see that a significant component of this comprises snow. And just to point out on the map that this is where the Bow Glacier is. This is where the Bow River emanates from. And then it makes its way down through here. And we're going to be talking a lot about Canmore and about Calgary as well. And then it heads on down all the way towards Medicine Hat. And I've got some data to show you from that area as well. So why did the flood happen? Well, it sounds like a bit of a self-evident statement, but the main reason was the amount of precipitation. And there was a lot of rainfall that occurred on June the 20th and June the 21st. And this map here, the area in pink here is more than 20 centimeters of rain that fell in a day. And just to put that into perspective, that's basically almost the yearly rainfall that fell in one day. So really, we were asking for trouble. But in addition to that, we had saturated and frozen ground. So that helped to kind of allow all of this water to just, instead of percolating into the soil, to just run off and run straight into the rivers. And it caused a great deal of erosion. And one of the things that people have often said to me is, but wasn't there a big amount of snow that year? Wasn't the snow the problem? And the interesting thing is that actually the record snow cap in the area was in 2012. And as we know, there were no problems with flooding in 2012. So that wasn't really a contributory factor. It was the frozen ground. And then what happened was that the weather played its part in this as well, because we had a high pressure system in northern Alberta which blocked the passage of a low pressure system to the south. So just to go into the weather a little bit more, this is what the maps look like in 2013. So we've got this area of high pressure in here, and this is actually caused by the jet stream, which is outlined here in this white arrow, and it got this kind of kink in it. And once it got the kink, this high pressure area got stuck. And so what we ended up with was higher pressure area here with higher temperatures, and a lower pressure area down here just to the south of Calgary. And that started drawing water all the way up from the Gulf of Mexico. So this second diagram here, you can see here's the Gulf of Mexico way down here, and the water is coming all the way up to Calgary. So despite the fact that we had a flood, it's kind of nice to know that at least the water was coming from somewhere warm and tropical. So I've got another diagram here which shows this in a bit more detail, and it shows this weather system coming up here, percolating around, circling around, and basically doing the same as this map here. But the interesting thing about this map is that if you look at the date, it's from 2014. So it's not like this weather system was a one-off. This is something that happens regularly, year on year on year. So beautiful evidence here. You see these dark green areas here, which are the clouds. And you can see exactly how everything is circling around here. So we've got another high pressure system sitting just up here, and that's forcing these weather currents around. And what happened in 2014, there was a really massive flood, which no one has ever heard about because it really hit Milk River and the areas around Milk River. So we get to hear about the ones that affect our big cities, but we don't get to hear about the ones that affect the small outlying towns, even though they may be just as serious. So I'm a geologist and I like field sketches, so I put together a very simple sketch to summarize what happened with the weather. Warm, damp air from the Gulf is drawn up all the way across basically the whole of continental America, up into Alberta, and it gets to here and it's stuck because this big high pressure area is sitting out here. And it traps this water over the kind of Canmore area in this low. A lot of rainfall here, some rainfall in Calgary, but I think you guys will probably remember it wasn't like it was just pouring with rain. I remember standing out there all morning looking at the flooded river, and I don't remember getting wet. So the rainfall was really up here in the Canmore area, and then it made its way down the Bow River, and also partly from the Elbow River into the Calgary area. So what were the impacts like? Well, let's start off by looking at Canmore, and in fact the area called Cougar Creek, which is, if you drive through Canmore, you've got the main town down on your left-hand side, close to where Chinaman's Peak. I know that's politically incorrect, but that's what I think of it as. Anyway, that's where most of the people live, but now they've started colonizing the area to the north of the highway, and that's Cougar Creek area. And that's where the highway is running. You can see it running along through here, and then this is Cougar Creek running down from this big catchment area in here. And as you can see, more than 10 billion litres of water were fed through this small gap, which is this gap here, which is the Cougar Creek, running down from the mountains into the main Bow River in the valley. And this is what it should look like, this alluvial fan, which this is racing over, the creek is racing over. But through time, there's been a lot of development in this area, and it's just been built up, and they've been forced to constrict what was originally a big fan, which the river flow could run all over, has now been constricted into this kind of man-made channel that sits in here. So this is just a before and after. This is June the 19th, and this is June the 20th. So in one day, we've gone from a kind of a trickle through to something which is gradually becoming a raging torrent. So the channel, this is what the channel ended up looking like. So you can see that things have really changed just basically in one day. So what's happened is that you've got these debris flows making their way down from the, kind of like landslides, making their way down from the mountain with a lot of water. And then when they enter the river, you basically end up with this slurry. And there were blocks in here the size of cars that were being washed downstream by this current. And the major problem really was, as I mentioned, that you had all this development. You can see these houses that have really rather unwisely been built right along the edges of Cougar Creek. And this one in particular is quite nice, that's just showing this building falling apart. And I talked to a friend of mine who actually, he lives on this fan, which is also not very sensible, but he was telling me that one of the guys who borders the creek here, he had a 108-foot plot. And after the end of the flooding and Cougar Creek had made its way through and eroded, he had 7 feet left. So that was quite an expensive investment decision that he made. Now, I talked a little bit about all of this development that took place. This is what the fan looked like back in 1947. And you can see the highway is already going through here. You can just see that faint line. And then things really started going crazy in the 70s. And then through into 2013, you can see that we have absolutely full-on development there. The whole fan is now compromised, and our little Cougar Creek here has been forced into a zone where it doesn't want to go. And it just shows that you can make rivers go into little channels, but that doesn't mean that they're going to stay there. And they did a big remediation project in 2012 where they restored all the banks, and they made all these banks really nice and strong so that only a really serious flood could affect them, and that's exactly what happened. So this is just a little bit of geology, but this is actually taken from the Canmore, Town of Canmore website, which is pretty impressive that they've done this work. And this just shows some of the work that was being done when they were actually digging through to try and get the channel back into some kind of shape. So this is kind of post-flood. And what we're seeing in here is that little bit there, that top 9 inches, is what was left after the 2013 flood. But look at all these other floods going back into geological time. And these were probably going back over thousands of years. But it just shows that this is nothing new in this area. And really, you should expect it rather than be surprised by it. There were serious consequences to the highways, but Canmore was completely cut off from the world for a while because both Highway 1 and Highway 1A were both washed out. So even if I'd wanted to leave my field trip that day, we would have actually had to swim across to get to Canmore, to where I wanted to go and look at the rocks. But anyway, as you can see, the highway itself was eaten into. This is another lovely before and after shot. Here are the three witches in the background there. And you've got the highway running through, beautiful sunny day. And then this is the day after, this is about June the 22nd. And you can see that basically the highway has been totally eaten away by this flooding. And once again, this is Cougar Creek here, which is no longer a little 2-meter wide creek, but is spreading out to try and become an alluvial fan and basically eating its way through the highway here. So, and that's another nice picture here as well to show what happened to that little creek when the flood started. Let's turn to Calgary now. And in Calgary, I live in Calgary. In fact, I'll talk a little bit about where I live as you'll see through the talk, because it gave me a nice chance to look at the flood from close up, since my house was getting a bit damp at the time. And over 80,000 people were evacuated, and they were evacuated from these areas here. So this is the Bow River running through there, and then this is the Elbow River running up through here, and obviously the main areas of evacuation were from these areas. So 80,000 people out of a population of 1 million were evacuated. And downtown was completely abandoned for a week or more, and you could still get through there and go and have a look. But as you can see from this diagram, where I've just colored in pink, this is the route of the rivers. So this is the route the rivers should be taking. And then basically this pink area shows all of the area that was flooded around Calgary the week of the floods. And what happened to the Elbow River is it basically went instead of running around this big bend here, it actually cut through the other side of the stampede grounds. This is the stampede grounds here for anybody who's ever been to see the stampede, that area there. So around 60,000 homes were damaged, but what was really nice about Calgary was the volunteer spirit. And I turned up for a couple of volunteer things where they were saying, we'd like people to come and help us to clear certain areas which we're having trouble with and to help people get their homes sorted out. And they were asking for 500 volunteers, and 7,500 would turn up. So this, and partly because people couldn't go to work, I mean, let's be realistic about it, but they could have stayed home and watched TV coverage of the floods, but they all got out there. And in the end, the city was awarded a governor's award because of the amount of volunteerism. And everywhere you went, I helped out actually along the lower Bow River in quite a quiet area, and I went there thinking, well, I might be the only person here who's shoveling silt back into the river. But there were tens of people. It was really fantastic volunteer spirit right the way through the city. So I just pulled these together as some typical challenges that we faced in Calgary, and obviously there are a lot of flooded houses here. This is close to the downtown area in Sunnyside. The stampede grounds were flooded, but 2 weeks later they had this clean, dry, and the stampede went ahead. So really very impressive. The transit system had some real problems. This is the going down into a tunnel, and basically that line there is the line where the water starts, so that all of the subterranean tunnels that the transit system went through were damaged. The track itself was heavily damaged as well, and this is also the transit line heading down into its water-filled portion here, going down towards downtown. A lot of problems with the roads, warping and erosion and scour, and then a lot of access to areas that they were flooded as well. And despite the fact that the vast majority of people were able to go and stay with friends, there were a lot of refugees, and this picture here is just typical of what was happening in Calgary, but there was a really good spirit in there as well. And a lot of garages and things were flooded too. And it's quite interesting that any cars that were flooded had to be written off because of the risk of E. coli that was coming out of the floodwater. So why were things so serious in Calgary? Well, the river was around 14 feet above its normal depth, and that really affected the whole area. And this is Inglewood, so this is where I come to work in the mornings. So this is late 2013, and this is June 2013, and you can see the sign is partially underwater. And yeah, at peak period, 14 feet higher river levels than normal. And the reason why so many homes were damaged was that the river was cutting across. Where it normally made a big meander bend, the river was just cutting straight through the middle, and a lot of people had chosen to build their houses on these low-lying areas. Now, this picture here I took standing up on what's called Scotchman's Hill, which is close to the stampede grounds. And I was standing there with a friend of mine who's a vet, and he looked out and he said, do you know, I never really realized why it was called a floodplain. So there's your answer. These are just a few pictures that were taken by somebody who has a lot more money than me with their own private plane. He works for Shell rather than for Husky, so that tells you a lot about Shell. And he took these pictures flying over the city during the flood. And in fact, very lucky for him, he was one of only 2 planes that was allowed access to the air during the flood. So they took a lot of pictures. And this is just to show these are all roads here. But those roads, the reason why they have that kind of shiny sheen to them is that they are all underwater. All of this area here is underwater. And you can see there's a lot of dramatic flooding here. This is the island close to the center, Prince's Island, which is all underwater as well. The zoo is all underwater as well here as well. So very challenging times for Calgary. So just to talk a little bit more about wildlife, there were some very exciting stories in the news. One was that the lions and tigers were going to be relocated to the town jail, which was an urban myth, but quite a fun one. Actually, the urban jail would have been worse. It was nearly flooded itself. And then there was this fantastic story about the hippos that were able to get out of their enclosure, and they were floating around, still inside, but kind of free-ranging. And they could theoretically have just gone out of the door and floated into the river. So we could have ended up with a kind of resident hippo population in Inglewood, because this is where the zoo is located, which would have been very cool. This is just a nice picture of a lady who caught a fish in the street outside her house as well. So despite all of that damage to the zoo, $60 million of damage, the only casualties were some fish, which is kind of ironic that these fish, they were in this area here, in the hippo enclosure, and they didn't like the water that came in, and they died, and 1 peacock died as well. So it could have been a lot worse. So I'm now going to talk about my specialist subject, which is sedimentology. And hopefully a few of you in the audience are going, oh, yes, sedimentology, I know all about that. But a lot of you will be wondering, OK, what's this all about? And basically, it's the study of sediments. And I've got your kind of 101 here on sedimentology. This is all you need to know to understand about the flooding. The 3 terms that I'm going to throw at you, or the 4 terms, are crevasse splays, which is basically just another name for a flood. So here's an example, not from Calgary, where you have a flood coming out from the edge of the river and just breaking its banks and flooding out. So those are called crevasse splays. And the deposits, the sediment, is called a crevasse splay deposit. So if I mention that word, you know what it is. Then we have 2 kinds of rivers, normally. Up in the Rockies, more typically, where you have steep gradients, you have what are called braided rivers, which have this kind of braided pattern, a bit like braiding your hair. And that this example picture here is taken from a plane ride that I took to Regina. One I'll never forget. What a lovely place Regina is. And I had to fly there for work. So this is a picture of a braided river. And then the other kind of river is a meandering river, which is one of these rivers that's just kind of wiggles backwards and forwards. And this is it wiggling, also taken from just to the east of Calgary, as you're flying across the plains there, the prairies. And these areas in the middle here of a meander, so the kind of encaptured areas in the middle are called point bars. And so we'll talk about those as well. So that's really all you need to know. Braided rivers look like braided hair. Meandering rivers wiggle. And they have these point bars inside the meander bends. As simple as that. So first of all, let's talk about those flood deposits, the crevasse splay deposits. And I went down to near Medicine Hat, and we looked at the South Saskatchewan River there, but the equivalent of the Bow River. And this is what we saw, was around 50 centimeters of mud that was drying out and forming mud cracks. But there was quite a lot of deposits there. So I wondered how much would be deposited in Calgary. And you can see this is a little slurry area in Calgary. This is in the zoo. This is what the zoo looked like. But actually, when you come to look at Calgary in detail, there was surprisingly little sediment deposited. And so what I did, I went out to this area here. So here's the Bow River coming down. Inglewood's just over here, for those of you who know Calgary. The highway, Deerfoot, is coming down here. That's Deerfoot there. And so I went to look at this area here because I could see that there were flood deposits there. And I was pretty excited. So being a good old geologist, I took my trusty spade, whacked my spade down into the ground and whooshed my foot on it to push it in. And what I found was that actually there's about 1 centimeter of flood deposit there. And the rest of it was just gravel underneath, just typical river gravels left over from thousands of years ago. So despite the fact that we're only maybe, 400 meters away from the river, maybe 300 meters away from the river, the amount of deposition there is tiny. So there's actually very little remnants of the flood, almost nothing to show that the flood had ever been there. You can just see here with the eye of faith, if you look at these darker areas, that there's some kind of rippling going across there, but it's pretty difficult to pick out. And remember, once again, this is only maybe a centimeter or a centimeter and a half thick. So surprisingly little sediment left behind. One thing that did happen was that we created some more braids in the river. Remember I talked about braided rivers? Well, you can see here we've got a few little islands which are called braid bars. So they're just little islands that are created in the river by the gravel as it goes downstream. And this is pre-flood and this is post-flood. And just to make it a bit easier to see, I've colored it. So you can see that the bars are built up dramatically. And this is the Elbow River coming out here, which was also heavily flooded and running 5 to 7 times its normal discharge. So the intermingling of these two river flood events created some quite significant bars there. But I like to hazard a guess that, we know there's been lots of floods in the past, so these bars will gradually be washed away. So you won't see any long-term effects. Now, flooded point bars, I already talked a little bit about how rivers cut across the bends when they get high. So this is the normal river flow path here. This is in the Bowness area. And what's happened is the river has basically just made its way straight across here and just flooded it through. And there's another nice point bar here, which is Inglewood Golf Course, built on this nice flat, fertile area in the middle of a meander bend. And as you can see, the same thing has happened there. And then out here, this is down close to the Stampede grounds. Here's the river coming down. And there's an old oxbow lake. There's an old lake here which had been built on as well. So there's houses that were built because it had dried out and it was all nice and fertile. And then the river comes in, it floods again, and it re-floods this oxbow lake. So we're seeing kind of like old topography that had happened being recreated when the flood comes through. A lot of erosion as well, and the most significant bit of erosion, once again, was in Inglewood, where I lived. I was really lucky, you know, in a lot of ways, apart from my house getting a little bit flooded. I was very lucky that I was right on the site to see these things happen, because we had 60 meters of erosion here from the edge of the river. So the golf course that I showed you the picture of in the last picture is over here, but so there's river flowing through here, but it's scouring away on the outside of the bend, and it's scoured into that area. So this is what it actually looked like. Here you can see it's actually scoured into the roadway that goes along there. And overall, the river destroyed 31 kilometers of pathway along its banks. So these are all areas, all of this stuff in red and all of this flagged stuff was where the paths were washed away, and it still hasn't been replaced. And also the scour affected the rivers and bridge foundations. And you can see here, this is from Fish Creek, where the edges of the bridge have all been washed away. The middle still survived because there's not much to scour there, but the edges got washed away. And we had another exciting event in Inglewood about a week after the floods, where the bridge collapsed with some toxic waste being transported in these railway carriages. So we all got evacuated again for the second time because they were worried that these might spill out and detoxify the whole area. So it was pretty dramatic. This is what it looked like here. You can see what's happened is this is collapsed due to the scour that's happened around the edge of the bridge stanchion. So there are also a lot of trees were washed down and kind of flowed down, but I think the trees will recover pretty easily. So it's more, the scour is definitely more of a problem. So just to summarize the geology, not much deposition, so very little sediment deposited. And so if you do ever see those big sediment deposited during a flood in geological record, it shows that it was pretty serious. And probably scour had the greatest impact on what happened. So we're now going to talk about the flood statistics and what happened back in the day, in the past, and see what influence that has on our vision of what might happen in the future. And this is a picture from 1897, looking west from the edges of the Bow River. So downtown Calgary is just kind of over here. And this is what things were like in 1897. And the 1897 flood was a lot bigger than our flood in 2013. 2013 was around 1,700 meters cubed per second, passing a certain point. That's what they measure, but we'll just say 1,700. And look at our floods back in 1897 and 1879. They're sitting at around 2,250 meters cubed. So 1,700 in 2013, 2,250 back in the day. So there is the potential for much bigger river flows than we saw in the flood this time, which is not really a good sign. So looking at the Bow River, it's kind of a nice thing to say that the discharge during the flood was 30% greater than the average flow over Niagara Falls. So any of you guys who've been to Niagara Falls, just picture that we had 30% more than that in Calgary. So one of the theories that I talked about earlier was that maybe this was a one-off, maybe this is something that doesn't happen very often, maybe it's a weird weather pattern. So what I did, I went back and looked at the 4 basins in our area. So we have the Red Deer Basin here in blue, the Bow Basin, so the one we've been focusing on, our one, in red, reddish-brown. We have the Old Man River Basin in green, and we have the Milk River Basin in purple. So these are all basins that are within our area of interest. And when you look back at the floods that have happened in these basins, you can see there's been a lot. So this is 1897, this is about 100 years. And in that time, there have been about, 40 floods? And some of them have occurred in more than one river at the same time. So sometimes there's been a storm system which has hit all of the basins, or 3 of the basins. What I've done is I put lines through to show, here's a flood in the Milk River Basin. You go up. No sign of it in the Old Man, no sign of it in Calgary, and a little bit of sign of it in Red Deer. So some of the floods occurred in large areas, but some were small areas. So basically, there's serious floods every 5 years or so, but it's really just where they occur. So you can't say, well, I don't think there's going to be another one of those, because there's one of those every 5 years or so. So that's just a kind of take-home message from looking at this regional data. So there's a few studies that have been done, and Golder and Associates have been heavily involved. And just to show you once again, this is the real data here in green. So we've got 1879-97, which was around 2,200, and 2013's flood, which is 1740. And then these are what the studies found. This is what Golder and Associates told the government was going to happen. They said in 1968, The maximum flood could be around 2,800. They did another study 10 years later, and the maximum flood had dropped to 2,200. They did another study in 1983, and it dropped to 1980. And then the 2010 study, it's incredible. It's just going down and down and down. So as time has gone on, the chance of a big flood is getting lower and lower, and the size of the flood is lower. And it's now got so low that it was lower than the flood we actually saw in 2013. So I think what that really tells us is that reading Golder and Associates reports is probably a bit of a waste of time. And I apologize to anybody here who works for Golder and Associates. Great company, but flood-wise, maybe not. Okay, so the next flood, and this is the big question that everybody is asking. What is the chance of the flood happening again? Well, we've already seen that there's been floods right through the last 100 years. There wasn't a big gap in floods through time, even though if you look at the data, it shows a real quiet period from 1932 to 2005. But that was because the floods were happening elsewhere. There's around a 63% chance of getting a 100-year flood in a 100-year period. So a 100-year flood is a flood that happens on average once every 100 years. But with the power of statistics, we can see that there might be 200-year floods in one 100-year period and then none in the next 100-year period. So you have to kind of average everything out. But if you do the math, or maths, as I would say, being a Brit, it shows you there's about a 26% chance of a 100-year flood in a 30-year period. So that means that there's a 1 in 4 chance that we'll get a repeat of our flood in the next 30 years. But actually, our flood is not a 100-year flood. If you look at the data, our flood, in the kind of scheme of things, in terms of the size of the different floods we've seen, our flood was about a 70-year flood. So once every 70 years, we're going to get a flood like we got in 2013. So that 26% chance goes up to about 40% chance that in the next 30 years we will get another flood like that. So there you go. 40 years, 40% chance. 30 years, 40% chance. So good chance of a repeat. So let's talk a little bit about what's going to happen going forward. Well, how would you present it happening again? Canmore put a kind of debris net across the Cougar Creek. They basically remade Cougar Creek so it looked like Cougar Creek in 2012. But other than that, it looks like there's a great chance of it happening again. The knee-jerk reaction of the government in Alberta to what happened in Calgary was they said they were going to buy out the properties that have been worst affected. So the properties in this zone were going to be bought by the government, and they were going to stop new development there, which also is not that helpful. And I'm just looking at the areas that are delineated, and I put my house on this map just to show that I have a personal interest here, because this is the area that's defined as floodway. So if your house is right on that dark red area, you're in trouble. But flood fringe, you're going to have trouble getting full flood insurance. So that's my area there. So I'm right on the flood insurance trouble area where my insurance is a lot more expensive than it should be. Anyway, the government had some other pretty wacky ideas, and one of them was to build a tunnel from the Canmore Dam all the way across to the Southern Bow River here. So downtown, as you can see, is up in that area there. They said that it would cost around $300 million, and Nenshi, he said that it sounded like science fiction. I think the price sounds like science fiction. To think that they're going to build this massive tunnel all the way across here for $300 million, that sounds a bit optimistic. They're also going to put a big dry dam in, which is going to be in this area here, which would just allow a kind of spill-off area for the Elbow River rather than the Bow. And then for High River, they're also thinking of a kind of extra channel that's going to take the water. This is the Highwood River coming in through here and coming back through here, so they're going to try and cut out the High River area as well. And that's about a 7-kilometer tunnel. So we'll see whether those things take place, and we'll see whether they actually have a strong impact. It's quite interesting that the dam had been actually emptied before the flood. And the idea was that this would provide extra room for the floodwaters to go into. And this is only the Elbow River. This is the little river, the Elbow River, not the big Bow River. And the Canmore Dam refilled in 7 hours. The whole dam, from nothing, it refilled completely in 7 hours and was spilling over the top of the dam. So that was really what you could call a temporary solution. This is just to give us a little bit of a warm feeling about what's actually going on with the monitoring. So we've got 400 stations, 600 meteorological stations, all recording data on the flood. And they're over this whole area here. And there's a river forecast center with 24/7 operations. And if there's significant rainfall, then they'll issue advisories. then stage 1 alerts, and then a stage 2 flood alert. So the plans are in place. It's not like people aren't doing anything to try and control the floods. One of the interesting things about the floods is that all of the big floods have happened in June. So we've got a pretty clear picture that June is the time to be on our guard. That's when to start stashing the sandbags in your back garden. Okay, so just to conclude, the cost of the region probably around $5 billion in total, and overall this was more costly than Hurricane Katrina. And in world terms, we were the 3rd most expensive disaster of 2013, which is pretty significant when you think of the kind of terrible events that happen around the world, that we were the 3rd most expensive in the world that year. I really feel that there was a great chance after 2005, and I was here in 2005 as well. I actually came for a conference, and I managed to turn up just as the flood was kind of ebbing away. But there was a great opportunity there to start putting plans in place, and it just clearly wasn't done at all. And even though that flood was a lot smaller than the flood in 2013, so there was really a chance missed. A lot of people had trouble with their sewage backup in their cellars, and the sad thing was that this wasn't covered by insurance as well. If the water flooded in through your window into your basement, you were covered. If it came up through the sewage pipe, you weren't covered. So that was an extra reason why the actual insured versus the non-insured costs were so different. And as I said in looking at the statistics, this is probably only 60% of the maximum discharge. If you think about that 2,800 meters cube per second passing a certain point, we were kind of only just above halfway to a maximum flood size, which is pretty concerning. And there's probably a 50% chance of at least a 2005 flood happening within the next 25 years. And as I said, about a 40% chance of another 2013 flood happening within the next 30 years. So nearly half. So final take-home message is, remember that fans are fans, so the people in Canmore, don't try and make your fan into a small channel because it's going to revert when there's a big rainfall. Probably need to look at dam management and how their dams were handled, because the people who own Ghost Dam were rigidly opposed to actually doing anything about the flood with their dam. And had they got involved a little bit earlier, it probably would have reduced the intensity of the flooding by about 10%. It still wouldn't have helped in totality, but it would have helped. I think a lot of new studies are needed to try and go back and say, well, why were the Golder and Associates studies so inaccurate now, and what really needs to be done to help us understand the flood better? And it's good to see that there's this continuous monitoring, but I would say to everybody, this is not the last time this is going to happen, so be prepared. And I'm just going to finish by showing you a picture of at least one person who really enjoyed the flood, and that was my daughter. So thank you very much.